Let us begin in the name of our Lord. There are several product rules of vector calculus which are used in physics. One of them is this product rule. Del dot A cross B is equal to B dot del cross A minus A dot del cross B. This rule we are going to use in deriving Poynting theorem. There are some students who may not be familiar with it, and this short video is meant for the help of those students. Those who know it, they can simply skip this video lecture completely. To begin with, how to go for its derivation? Simple. We shall be using cross and dot product definitions. For dot product, for example, if you have P and Q as two vectors, then their dot product P dot Q is simply PXQX plus PYQY plus PZQZ. That is Px multiplied with Qx. This dot product differs from ordinary this algebraic product that for example PQ, it differs from that in the sense that there are no cross terms. There is no PXQY, for example. So you have PXQX, PYQY, PZQZ. Okay, that is the definition of dot product. Now again, so as the definition of cross product is concerned, it is this: P cross Q. That is a short way of writing it is, we write it I, J, K. These unit vectors are needed because P cross Q is a vector itself, and we have Px, Py, Pz, Qx, Qy, Qz. You can immediately see that when you take x component of cross product, in x component you will have cross terms Py, Qz, Pz, Qy, and so on. So beginning with this, let us now write del dot A cross B. What is this del dot A cross B equal to? It is equal to, first of all, let us write del explicitly. That is I cap d by dx plus j cap d by dy plus k d by dz del by del z dot A cross B. Now A cross B is, once again we will write it in determinate form, I, J, K, Ax, Ay, Az, Bx, By, Bz. So we will now first expand this. Keep that as it is. When we do that, we have I del by del x plus j del by del y plus k del by del z dot. Now we have here I, first term of the cross product, I ay bz. Let me include this curved brace here, ay bz minus az by. Then I have another term, that is minus j cap is equal to into ax bz bz minus azbx, and then lastly plus k cap, that will be k cap, that is ax by minus, so it is ax by ay bx. Good. Now we will have to dot this with this, and as you're seeing, this term will be dotted with this, I cap with I cap, j cap with j cap, k cap with k cap, no cross terms. Therefore, dot product. Look, this is dot product here. Of course, this is a vector. This is a vector, but this dot product will reduce this to a scalar. So you have del by del x, ay bz minus az by, then minus del by minus, now del by del y, you have del by del y, then ax bz minus azbx plus, you have k cap with k cap, you have del by del z, k cap with k cap, that is ax by minus ay bx. Now this will, when we use u into v rule of calculus, ordinary calculus, now these are scalars. Now when you use that u into v rule, this term will give you, this much will yield you 2 terms. This will yield 2 terms. Total number of terms that you will get from in this first line, it will be 4. You will get 4 more terms here. You will get 4 more terms here. So we have this situation. Patience is what is required, and you are requested to be, of course, to be patient with me. Now you have del by del x, you have to differentiate this. First let us differentiate this bz. It doesn't matter, leaving ay aside. Del by del z bz, del by del x bz. We have to be careful about these subscripts. Now this is u into v, so I have written u into dv by dx. Now I will have to write plus. I will now differentiate this, leaving bz as such. Bz del ay by del x, okay, minus, then minus this. Now differentiating this, leaving az as such, az into del by by del x, then minus, which minus, this minus will go, will proceed ahead, and you will have by del az by del x, okay. These are the 4 terms yielded by this. Next I have here ax, as it is ax, and differentiating this, del bz by del y minus, because you have minus here, so second term from this will also be minus. That will be minus bz del ax by del y, then minus plus, that is plus. You have az del bx by del y minus, no sorry, plus the az bx del az by del y. Now lastly this plus ax del by del z. Okay, then we have this minus, plus we have still one more term here, that is by into del ax by del z. Then you have minus del, you have ay del bx by del z. Then you have minus, next minus del you have bx del ay by del z. Now what you have to do now is to collect the components of b and a separately. So you have, for example, you have bx, by, bz, three components of b, and you have ax, ay, az. So those terms, we will group them into two. We will actually make two groups. In one group, we will get bx, by, bz terms, and in another, we will get ax, ay, az terms. Now let us go for first bx, by, bz. Bx, or you can choose a. It is not must. You can choose this a itself. Anyhow, it doesn't matter. Let us choose a. Ax, ay, az. So you have ax. Now each term ax, ay, az will be in will appear in with two signs. For example, look at this ay. Here it is positive. There will be another term ay that will be negative. You can check it here. Ay, yeah, this is. So if we combine these two, you will have ay del bz by del x minus del bx by del z. Okay. As you can see easily, this much is not z component, y component of this curl, y component of cross product of del a and b. See how? Just a minute. Or first let us collect them, and later on we will tackle that thing. This is ay. Okay. Ay had two terms. So will be the case with ax, for example, plus ax. Or should I have written first ax term? Anyhow, I'm sorry for that. So you have positive ax term here, del by by del z, minus negative ax term here, del bz by del x, del y. Then I will have, this is ay, ax, then az, of course, az, and I will have, this is az here, az, this is az, but this might, these two are az terms, az del bx by del y minus del by del x. Okay, good. Now ay, ax, az, ay, az. Okay, I need now terms with b, y, bz, bx. Now you have first double plus bx, none in the first row, bx. Yes, I have one. This is there. Del az by del y minus now b, what I am looking for, bx. So I have it here. Another term, del ay by del z plus by. That is, now let us look for by term. By, we have one here, by, another by, positive by is here. So I have del ax by del z minus del bx. Then I'm looking for by. By is here. Del az, del az by del x. Lastly, bz. And let's see, where are bz terms? One is this, the positive term del ay by del x minus negative term bz. Bz is this del ax bz. Del ax, del ax by del y. Okay. All terms have been accounted for. Now consider this dot product first. B dot del cross A. That will be equal to B. So far as B is concerned, it will be I bx plus j by k bz. Dot. There will be a dot, and then there will be this determinant I j k del x, that is d by del by del x, del by del y. These are components of del plus del by del z, and then writing components of ax, ay, az. Now it will have expressions like, it will have, for example, this is a vector, so is this, but you are taking dot product between two vectors, so this bx x component will be multiplied with x component here. And what is x component here? Just look at this row and look at this column. X component is del az minus del ay. Del az by del y. This is here. Del az by del y. This and this. Del az by del y minus del ay by del z minus del ay by del z. So you can see bx into this, that is this much part, this into that. Then you will next have this j by will be multiplied with this. So we normally what we do, we take it as minus and then follow the same rule as we follow for I and k. But we can do a reverse of that as well. We can take it as plus and then reverse that. That means reversing it means, instead of taking first this product del az by del x, we will take first this. The two minuses will cancel then. Del, what is this? Ax. This is ax because it is in the column of this I. Del ax del z. Now del ax del z. This is this. Del ax by del z minus del a. Sorry, this was this. Del az ax by del z, and then we have del az by del x. So you have this second term. First term, second term, then third. Dz will be multiplied with z component, and z component is this del ay by del x. Yes, this is the del ay by del x minus. So this you can easily recognize. This is simply this dot product, b dot del cross a. So we can replace it here this much by this simple expression, then by simple this dot product. Similarly, let us look for this. Let's have a look at these terms which contain ay. Again, you have to simply write here a dot, check this, a dot del cross b. So once again you have A dot, that is IAX plus JAY plus KAZ. So then next dot, that will be del, I cap, J cap, K cap, del by del X, del by del Y, del by del Z. Similarly, Bx, By, Bz, Bx, By, Bz. So you have first the X component. Let's take X component. It is X component here is del Bz by del Y. Del Bz by del Y. X component. This is X. X del, I have got del Bz, no, it is here, del Bz by del Y minus, so it is reverse, del Bz by del X minus, del Bz by del Y minus, del By by del X, so it is reverse. So why shouldn't I do one thing? I take minus as common, and if I do that, I will get it this as minus term here, and these will be reversed. Now come to this term, ay. Now y component here will be in this, in reverse form, it will be del bx by del z, which is of course del bx by del z minus again reverse. That means we will have to take minus as common, then this will be restored in its proper form. Let us go to Z component. In Z component, you have del By by del X, del By, but in all the three cases here, you will have to take minus as common, and only then this will fit in this. I hope you understand all this. And then lastly, what we got, our basic product was del dot A cross B, which side it is equal to this is minus del minus what is it, minus A dot del cross B, A dot del cross B, A dot del cross B plus B dot del cross A, So which can be written as B dot del cross A minus A dot del cross B. So